Hello and welcome to another tutorial. So this time we are going to be continuing to build on the biome-based procedural generation. So we're making a few different updates to it. Previous one we were updating things there with the object placement, and this time around want to be focusing on some improvements for the height generation and also for the texturing. So these are based upon things that some better techniques that I've identified from a current project that I'm working on. So we're going to be bringing them into this and adapting them to improve this project as well. So first thing we're going to focus on is some changes in terms of with how the noise is used for the height generation. So we currently have noise-based height generation, and we can see we've got some settings there in terms of the scales, stuff like of that. We don't do anything on the post-processing, but we've got some X and Y scales there. We have a number of passes, and it does a fixed change per each pass. So what I actually want to do is I want to change this so that each individual pass we can actually control what the noise is. So it's not a constant multiplier, it's something where we can actually directly be changing and adjusting it. And that's going to, I think, give us some better control there over it. So what I'm going to do is set up a additional class, and we make it system.serializable, so the data will be able to actually be stored. So height noise pass, and what we'll do is each pass can have its own, essentially its own amplitude, its particular intensity modifier. So amplitude or intensity modifier, intensity scale. We'll default that to 1. We also want to have then frequency. Now we don't really need to have different frequencies in X and Y, so I'm actually just going to have the one sort of frequency or scale factor. Either terminology works for it. Might go for noise scale, and we'll default that to 1. So that's good. That gives us our configuration for that. And then what I will do is, because quite a few of these bits of data will actually then be going away, I'm going to set up, have a list of height noise passes. So I'm not deleting the old variables yet. The reason being is that I want to make sure that I can update the modifiers so that we have that all properly configured. So we've got our height modifiers. So this, I want to set up my passes. So we need at least one pass, and we can actually see this one did have 3. So we'll add in our 3 passes. We have our scale. So we'll put that in. So the variation is set to 2. And if we take a look at how that variation gets used, then it's a multiply. So that means this one would be times 2. That's something to always remember, that you can do simple mathematics in these cells. Really, really handy. The height variation, so the intensity will start at whatever the height delta value is, and then again gets multiplied. So our working height delta is set to whatever the default is there, which is 5. So we have 5, then it goes to 2.5, 1.25. I might actually change that to height delta. Is actually a better term for it. Oops, not that one, this one. So that means each individual pass will be able to control how much it's able to actually change the height by, which is cool. So it's going to give us a lot more control over it. It means the ordering of the passes and everything like that, we can easily change that, which is going to work really nicely. So I'll just get all of these set up. So we just need to, for each one, it's going to be the same process. Now, first, converting a lot of ones, this is something where I would probably set up a dedicated little bit of custom editor logic to import it. In this case, it's not too many ones, so I'm not going to worry about doing that. Initial height modifier has the same sort of thing. So that has quite a few passes. So that we have 5. So I'll actually just manually add those in. So we just need to make sure with each one, times 2, times 4, times 8, and then times 16. And so this will make it a lot easier just with us adjusting stuff. So 20. Because before, if we wanted to do a pass at a different, something that wasn't just a direct multiple, then we couldn't really easily do that, or we'd need to add on another modifier, which is very doable, but it's something that can get quite involved. Now, rainforest, that might be... No, it's not quite the same as this one. That's okay. We'll get our noise scales in. So the main reason why I adopted this change was I was finding I was needing to be adjusting the scales, and that I needed more control than just a single sort of simple modifier. I did find that I needed something where I was changing it by varying amounts at each actual sort of stage. And that by being able to do that, let me get some really fine-grained control, so I could adjust like the pass in the middle, stuff like that, which worked out really quite nicely. So this one's only 3 passes. So yes, if you had a lot of ones set up, it would be worth setting up some specific editor side of things. That would actually save quite a bit of time. But this was why I didn't delete the data beforehand, was just so I could go through and check and make sure number of passes, things like that matches. Because then what I will do is I will actually delete the sort of previous sets of data, but not until I've checked that it's actually fully working. So this gets 3 ones, same sort of logic. And the same setup with the scale. So that's good. So we've got the reconfigured data there. What that will mean is then down here, I will actually now delete all of these. I will delete that. This becomes a for each var pass in passes. Then this becomes multiplied by pass noise scale. This becomes pass height delta. And these disappear. So not much changes actually from the code side. Most of the changes we're doing are on the actual sort of update side of things. So in terms of the data, so very little needs to actually change from that point of view. Now before we run it, there's another height modifier I want to actually change. So we do have post-processing here, and one of the things we have is this smoothing setup. Now, one of the things with the smoothing setup is the smoothing setup is uniform in that the kernel size that it uses is exactly the same regardless of what sort of the conditions of the map. And what that means is that if we have high peaks, those high peaks can tend to get very squished. And it's going to be a lot harder for it to get sharp peaks because of the fact that we're averaging and smoothing everything. So what I want to actually do is have it that the smoothing kernel size changes with height. The higher we are, the smaller that kernel will be, so the more it will preserve features. The lower we are, the larger the kernel will be, so it's going to flatten things out. So this is a cheap way of achieving sort of something that's going to give a little bit more natural looking terrains without going fully to setting up like the sort of erosion based methods for it. So it's cheaper than that, but starts to give a measure of that effect in terms of, you know, preserving the peaks and flattening out the lower lying areas. So that's what we're going to set up. So in order to do that, we have a default kernel size, but then we're going to need to use adaptive kernel, which will default to off, but then we want to have a min kernel size, which that's going to be, let's go for 2. And then we'll have a max kernel size, which we'll set as maybe 7. So then how we actually determine the kernel size is, okay, well, int kernel size is smoothing kernel size, f, use adaptive kernel, and we're going to adjust that. So these I'm going to switch over, set the kernel size. So then I'm grabbing stuff from the raw height map here. So that means they're 0 to 1 values. So to get that kernel size, what I can do is, if I do a mathf lerp from our min kernel size to our max kernel size. So the min kernel size is going to be what we want to be using at the highest points. So in this case, what I would actually do is we could flip these around. Because if I then throw in here the height map height at this particular point, so what I would do is use the height map at X and Y. So that point, when it is 0, that means it's going to be very low, which means it'll use the max kernel size, and then it will go up to the min kernel size. So I'd say kernel size is equal to that, but I need to convert that to an int. So if I can do a mathf round to int, and then that should do the trick. We should have our adaptive kernel there. So we're going to test this out. First, I'm just going to run it without actually doing any of the rest of the stuff. Also going to, just if we want to test the height map generation and the texturing only, be kind of handy if we could skip stuff like the object placement. So what I'm going to do here is chuck in enable object places, and I might make this a debug one. I might call that actually turn off. And what I will do is where we have the spawning of the objects, we can do cleaning out. but the perform place of objects inside this, if that debug one is set, then we'll just return. It just gives us a way of being able to shut off stuff if we want to quickly iterate on things. That will just save a bit of time with it. And I'll make sure that's actually under a proper heading of debug options. Debugging. I do recommend adding in things like these little helpful flags, and flagging them and your debug things can be really handy. So we're going to turn that on, I'm going to save this, and then we should, at this stage, see not too much in the way of a difference, because we have transferred over the settings, so everything should largely be pretty much the way that it was before. So we can see those terrain environments are looking about right. So that's looking pretty similar. So what I'm now going to do is the post-processing, where this is where it does stuff like the smoothing. I'm going to turn on the adaptive kernel, and then we're going to see how this looks in terms of difference. So we're going to regenerate the world. So we should expect to see some differences there, and can see definitely shape-wise pretty significant changes there in the shapes of things, which is cool. It can smooth to a larger level, so that's probably something where we might change this, that the smoothing kernel, we go from 1 maybe to 5, so that'll give it something where it can be doing at the maximum height much smaller changes there. So we can see with that, it's smoothing out these lower areas a lot more. Now, height-wise, it's probably not getting anything that's sort of going up to too high a level, potentially. So we could also, with that sort of adaptive smoothing side, we could set a sort of maximum threshold, where that's considered essentially the max height. So if I set that to like 0.5, we'll give this, it's a range 0f to 1f. Bring this down here. Then what this will do is if the height, we're going to look at the height relative to that max height threshold. What that will do is that allows us to, because we're not generally going to generate stuff that gets up too close to that maximum height. So this is going to adjust sort of the ranges there so that we consider max height to be a much lower point. Because if we look at the terrain and settings there for it, the maximum height for the terrain can get up to 600. And I'm pretty sure we don't have anything. If I just create a quick little plane, we'll be able to see, but I'm reasonably sure we don't have anything that is going up to that height. I might position it at 0, 0. So that, if I position that at 600, you can see it's way up there. So the highest point we've got is probably around 100 actually. So if I make this much larger, then we can see we don't even actually get up to 100. So max height-wise, we're actually not going too high with the terrain. We're keeping that down quite low. So that threshold would mean that I think that adaptive threshold, we can probably consider our max height effectively to be like 0.1. So that's going to change the thresholds here. It's going to mean it's going to generally be smoothing less because we've effectively brought that ceiling down. So as we can see there, got a few, it's preserving those peaks a lot better, and we're able to get those sharper sort of edges for this terrain because of that different sort of smoothing approach. Because at these high points, so something like this is a good example, that would previously have gotten just completely eroded by the smoothing. But because of the change there, because we're using that adaptive smoothing, it's able to be preserved. So this is the big advantage of that. Okay, so we've improved the generation here, and that's looking really quite good. So that threshold, how we adjust that, I would generally recommend you want that effectively that value there for the height, so that max height threshold, that you want to have that be essentially whatever the highest point is that you're generating in the map, have it be around that, maybe a little bit larger. Like if I did raise that, it would go and smooth out some of these a little bit more. So if I ran that, it will smooth some of those a little bit further. And as we can see, things are generally a lot less jagged now. So that's something where that's how we want to adjust and balance that. But it's going to preserve those higher altitude, sharper features a lot better. What I want to now do is improve the painting. Because at the moment with the painting, we've got our random painters. We've got ones that can paint based upon height and slope. But it's the random painter that I want to focus on improving, because I think there's a bunch of things we can do to actually make this a lot better, because we might want to not just uniformly paint something. So how I want to improve this is I want a bit more control over the intensity of where things are being applied. So being able to do more than just pure random with it. What I'd like is to be able to modify it with noise. So similar to the height modifier for the noise, we want to store some extra data. Now I've already got this texture config, so I want to just refresh my memory of where I'm using texture config to decide whether that is something that makes sense for it to be configured in there, or whether I need to have a little bit of a different setup. So that's created in our texture painters, and each of the texture painters do use it, so it might be a little bit confusing if we actually had it in that. So this is where, again, using a system serializable public class random painter config, this will have a public texture config texture. Now texture might already be a data type, so I'm going to call that texture 2. It's texture 2D. I'm going to call this texture to paint just to avoid potential collisions or confusion with it. I'm also going to set up with this. I want to have a noise scale, which we won't give it an initial value, and we'll have a noise threshold. And, for good measure, use perlin noise, or use noise. That way, if we want something that is just pure random, it can be pure random. Otherwise, we can use a perlin noise with it. So I'll set up serialized field, list, random painter config, painting configs. So this is going to be similar to what we needed to do with the other ones. We're going to need to transfer these settings over. Now, these are a little bit simpler in terms of what we need to be doing here. And this is something where I may be able to copy and paste these in, which I can. So that makes that a little bit easier. I will want to sort of double check that it has properly transferred things over. And that is something when you're copying and pasting within a prefab like that, that you could get odd behavior. That absolutely can happen. But this is a case where we can paste these in. So we can copy and paste. And I'm just saving after each one just because I want to be confident that it has properly transferred the data. Not that I don't trust it, but I don't trust it. Paste, and same thing. So it should be all the ones. We just need to transfer over for swamp. So get each one copied. This is a thing in the newer versions of Unity. You can just quite happily copy and paste specific properties like that, and it can work with classes and everything quite well. So that's good. We have the configs there then. So now it has potentially multiple configs that it could apply. So this actually changes our behavior a little bit, because before it would pick a random texture and then apply that, whereas now it's going to actually do a little bit more logic than that. It's going to be able to apply multiple textures to the same location, which is cool. I will also set up so that we have public float intensity modifier is 1. So then we've got the location, we've got our height map, everything like of that. So what I would then do for this is I'm going to go through the painting configs. So for each config in painting configs, then what I want to do is, with each of these, check if it actually can be generated at this point. So I can, for the noise, that's going to be the easiest way to get this. Is going to be to bring this here. Now perlin noise gives us a 0 to 1 value, so I can just change this. So we get the noise, and then if our random value is above that noise threshold, then that means that we will paint. So if random range 0 to 1 is greater than or equal to noise value, then we will apply it. So this is only going to be f config use noise. So if config is set to use the noise, then what we'll do is we'll just bring that up here. So we get our noise value. Check if noise test passed. If it did pass, then what we will end up doing is, so this, we can go for config dot texture to paint, and the strength gets multiplied by config intensity modifier. So I'm going to move this here just so it's a little bit cleaner and neater. So that's good. We can retrieve the data, perform the painting using noise. So this could mean that we have cases where it ends up not applying a texture and we don't have this random behavior that we did before. But that's actually okay, because I'm going to make it not optional for there being noise. And I'm going to make it that there is a base texture that gets applied. And base texture, actually no, we already have an intensity modifier. So it's going to get a base texture no matter what. So base texture layer, because we do need to retrieve the layer. So we'll do manager, get texture, get layer for texture. So we don't need to check the noise anymore because we're just going to always apply it. So the idea is this is going, base texture layer, this is going to be something where the noise-based ones are used for accenting. So we have a base texture that will always lay down here, and then we have accent textures that we can add on top of that. And that generally is going to work out really quite nicely. So how this will then look is, well, our base texture is dirt. Rock becomes an accent texture. So it will have an intensity there. The noise scale, so that's something where I'm going to go for 132. And we'll just set a threshold of like 0.5. So that's good for bush. For grassy plains, we again transfer this over. Mud now, in this case, becomes the accent. And with the same sort of thresholds, so that's good. Rainforest is fine. The scrubland, we're going to use dirt as the base texture, with sand as the overlay, but a different scale and a different noise threshold. And then swamp, same sort of deal. So this will give us much sort of better appearance for this. I might make that 0.25. So it's going to change quite a lot how this gets painted, but the idea is we lay down this common texture, and then on top of that we apply accents to it, and that's going to end up looking a lot better. I'm going to put that in as a range. And same for the intensity modifier. So let's test this out. We should get pretty significant difference in the appearance. So that needs to be able to return a list of textures. So what that's going to have to do is list texture config, paste textures. So we return that, but if that is equal to null, then we populate that. So we can add in paste textures, add base texture, and then for each var config in painting configs. And so it's base texture that gets. And then these, we do paste textures, add, and our config texture to paint. So that way then it's still got that list of cache textures to be able to pass through, which is good. So let's test this out. We should get quite a difference in terms of how this appears. because we do now have these different thresholds and that being used. So let's run this. So it will take it a little bit. It's going to have regenerated the height. Now we did get an error. So that's failed to find a particular texture. So we just want to go through, and what that potentially is it may need us to regenerate the textures. You'll notice when we regenerate the textures in this version of Unity, and this is a new thing, we are actually getting an error. So where it's getting cranky is here, and it's now expecting that the file we give it, that it has the extension .asset, which that's okay. We can easily add that in. So with that added in, we should be able to successfully regenerate our textures, which it's regenerated them without issue, which is good. We can check in the terrain, you can see we've got the different layers set up there, so those are looking correct. So then we can go to regenerate the world. And we can see we get height changes. So we are still getting an issue here. So we're going to need to step into and debug this just to see what's actually happening there. So we'll regenerate the world. We did need to regenerate the textures anyway with the changes we made. So this has a base texture, so that looks correct. And then if we step into that, has the various lookups here. So you can see it's got the different texture configs. And we've got ones for water, snow, rock, and grass. So that's missing some of the ones. So it's got water, rock, snow, and grass, but we're looking for dirt. So it's not actually going to find it. So this is something where it's not actually grabbing all of the correct layers. And if we look at the terrain, we can actually see that not all of the ones are there. Now, the way that it gets this information is from getting the layers. So from getting that information from the actual modifier itself, which this should be going through every config and adding that in. So we're going to want to go and check this because this is something where when we go and rebuild the textures, that it should be getting run. And we can see there's definitely some stuff missing there when it runs. And we can see it's not actually ever running this. So this is not actually picking up this list of ones. If I regenerate again, now it runs it. So it's thinking it's got stuff cached and that that's null. So this is a thing that can actually happen, that sometimes I have found it's necessary to explicitly mark something as not being serialized. Otherwise, some things, even though they shouldn't be, can end up getting serialized. Now if we run this, cache textures is correctly null, gets everything added in. Terrain, if we now look at it, has all of the correct layers. And then now when we regenerate world, it's going to have access to all of those. So it's something to watch for. It's why you'll see at times I specifically will flag some things as system.non-serialized, because some things, even though they are private, still can end up getting serialized. They shouldn't. Like that is not something that should happen, but it is something that can happen. So we can see the accenting that sort of happens. And I find that using this approach, it gives you much better appearance. Like we get these patches the patches are actually organized and are grouped together, so it gives a much better overall appearance. So we've improved a bunch of areas. We've changed the height noise application so we can control each individual pass, its scale, its intensity, and that works a lot better for being able to vary and adjust things the way that we need. We also changed the smoothing there so that it uses an adaptive kernel, and that allows us to have a small kernel at the high points to preserve those peaks and those sharp edges, and also then a fairly large kernel lower to the ground so that we're smoothing out those areas and making them more accessible. So it gives us a better sort of profile to the terrain. And then we've updated the texture side of things so that we have a base texture that we can paint down. And then again, using noise, we can apply different accents to that. We also ran into a little bit of a thing where some data that shouldn't be serialized was still being serialized anyway. So we saw how we can actually fix that by explicitly going for something being system.non-serialized. And that worked out with solving that. So dive in and experiment with this. We've made a bunch of changes so we can now really control the appearance a lot better. So see what kinds of things you can be doing there with it, what kind of things you might want to add to it. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it's something that's really appreciated, really helps out. If you're looking for the code for the project, I've chucked a link for that in the description below, and you can find that up on GitHub. You can freely use that in any of your own projects, commercial or non-commercial. If you have questions, chuck in a comment below. And if you are looking for other ways to support the channel, I do have a Patreon, and there is a link to that in the description below. But until next time, bye.